Hi, welcome to MCP for DevOps Architecture and Components. My name is Shannon McFarland and I lead the CiscoDevNet and Cisco Open Source Program Office. We're going to get into what MCP is from kind of a light duty level. There's lots of content out there on the internet that you can get very robust descriptions and examples of what MCP is, but we're going to hit the highlights on MCP as a protocol, but we're going to dig into what MCP looks like from a messaging and wire format, what the client server architecture is, how do we actually do tool interactions and API interactions, and what does that look like on the wire? And then we're getting into a few of the other components such as resourcing, discovery. Is it really discovery? And then that will lead us into a series of videos and other content that will allow us to dig into applicable DevNet SecOps use cases, as well as hands-on implementations around MCP clients such as Cursor, Claude Desktop, VS Code with GitHub Copilot, and a variety of MCP servers such as GitHub, Argo CD, file systems, and databases. And we'll eventually string all of that together into an entire Cisco automation workflow, leveraging MCP to offload the toil it takes for us to link our tools together with AI and agents to get our work done. So let's get started. MCP is Model Context Protocol. It is a protocol that is designed for AI agents and other AI applications to effectively and in a standardized way integrate and communicate with non-AI components such as tools or data sources, APIs, those types of things. It is a standard way of getting that done utilizing an MCP SDK. It is extremely effective at allowing you to integrate clients. We'll take a look at what those look like in a little bit with all of these different data sources and external tools without you writing any code in your AI applications to get that done. It does utilize a client server architecture, so we'll talk about that. And it's utilizing lots of very familiar things on the wire, such as standard input-output, HTTP, and so forth. At the end of the day, like many protocols, MCP is plumbing, and we're going to take a look at what it looks like from a plumbing point of view. It is important to understand what MCP is not about as well as what it's about. MCP is not a messaging protocol for agent-to-agent communication. That is handled through things like the new agency open source project that's out there. I'll put a link for you to go and check that out. A2A, this is one from Google and many other ecosystem partners around agent-to-agent communication. These are tool sets that are in the open source world that are there to link up agents to agents. MCP does not do that. MCP is about taking agents or other AI applications and linking them with tools. And we're going to reiterate that case over and over again because there's a lot of confusion around MCP and other things that are in the market, such as agencies, ACP. And again, we'll talk about that in another series. But these two things are not in conflict with one another. MCP can be utilized by agents to communicate with tools, while that agent also simultaneously uses these other standards, such as agency, to communicate with other agents. And again, we'll differentiate that throughout the session and all the sessions to come. It is also not an LLM or a database or an assistant or a full platform that manages the lifecycle of all your tools. MCP also does not replace all of your APIs and all your data buses. So we'll talk about the use cases and what it is and isn't as we get into some of the practical use cases and implementations in the following sessions. Again, it is tightly scoped. I mean, MCP is a very lightweight protocol, as I mentioned before, and it's there to provide AI agents and other applications with a clean and standardized way to discover. We'll actually define what discover means. To request and invoke capabilities of existing or new tool-based infrastructures. So it is a way for things like your LLM with an application that needs to go and make a REST call or list files or talk to a database without you writing any of that code inside the agent. You're simply leveraging the MCP SDK to get this done. It really matters. MCP really matters because if you've done any of these agentic type applications or AI assistants that need to go and communicate with a diverse number of tools like web browsers and all kinds of things, while the code doesn't seem that bad, when you really start building lots and lots of these tools into your ecosystem of your AI infrastructure, that's a lot of code with a lot of updates, with a lot of potential vulnerabilities that you got to deal with. And MCP allows you to communicate through their SDK to these tools without you monkeying around with all that code. So this is very, very important. It's also extremely important for the community that my group supports, CiscoDevNet and the Cisco OSPO group, is that folks that are in the open source community or in the operational community that leverage programmatic tools to get their job done, what you don't want to do is have to learn all of these AI agent tools and how all that works, plus how do you go talk to non-AI native tool sets and write all of that code when simply all you need to do is have your AI-enabled application or an IDE go and communicate with a local file system or go and communicate with an API. That's not code you don't want to, that you don't really want to get involved with authoring. So this is what I find really appealing in the operational area around MCP. Now, there's lots of things around the architectural components that you need to probably go and read on that you're not going to get here. I'm really touching the highlights here so that you kind of understand the semantics of MCP, that it is a client-server configuration or architecture, and what the protocol does on the wire. But there's lots to actually know about MCP, and their documentation does a great job with it. As I mentioned, MCP is a client-server architecture. Now, throughout all of my documentation and my blogs and my video stuff, I abbreviate MCP-C to be client, MCP-S to be server, so that's just what those mean. And what you really need to understand is that MCP operates at a one-to-one connection relationship. So there is one client to one server. Now, that does not mean that your application is only bound to one of those pairings. We can see in this diagram that what MCP calls a host, which is an AI application, can have multiple clients talking to multiple servers, but only one at a time. And we'll talk about what that exchange and that interaction looks like in a little bit. There is an SDK, as I mentioned, that you utilize that's language specific, as SDKs are, that allow you to, on your client or on your server, leverage the same SDK to make these connections. And this is really great because it's a clean SDK. And what this does is it completely offloads, if not totally removes the toil you have to deal with in writing agentic or AI-enabled applications to these non-AI native tool sets. And so the SDK does that on your behalf. We also have this client and application model, as we mentioned before. The clients live in these AI applications, and then the servers are there to represent whatever tooling or data sources you're after. So we can see in this particular diagram that we've got a single AI application. It could be Cursor, it could be VS Code, whatever it is, that has two MCP pairings. The first one is talking to local data sources where I've got files or databases or something like that local to my Mac that I'm testing with, and those client and server relationships would be paired together. But I can also support remote MCP servers where maybe I'm talking to a remote database on AWS or a remote API call or a remote web browser service that's providing a search engine for me. And I can communicate with that all from the same AI application, but in completely distinct pairings. Now, MCP architecturally from a communication protocol is utilizing JSON RPC 2.0 as its exchange format. And we'll see several examples coming up here and what that looks like in the exchange. You also have two options for communicating between clients and servers. So for local connections between clients and servers, you can utilize good old-fashioned standard input-output. So stdio. So we can do input-output, and you can go read the specifications about exactly what's taking place there and how do you properly secure those connections if you need to. But that is a primary means for clients communicating to servers in a local host environment. Now, The second version of that is, or the second option there, is we'll talk about in the next few slides, is utilizing HTTP as a means of taking care of remote path connections, but also you can leverage those as localhost HTTP connections as well. Let's take a look at this from a local stdio example. So you can utilize an MCP Filesystem Server like I've listed here in GitHub, and we can run this once you get the dependencies all sorted out from what the documentation states. And we can run an MPX and point to the MCP server we want to run. And this is pretty much the standard way that you would do this from a local host point of view. You would point to at model context protocol / whatever the server is, in this case, server-file system. The server file system has additional properties or additional arguments that you can add to it. One of these being that we want to restrict access to a very specific path on my computer that the file system has access to. In this case, it is to this path that you see with MCP-testing. Once you run that, you'll see that the server is running and that you now have it allowed directories of this specific path. So that takes care of the server on the local host ready for an stdio connection. Now, what we want to look at is the client to server pairing. So we talked about setting up our file system server in our local machine, but there's lots of options for clients. And as I mentioned, Claude Desktop and Cursor and many clients that are out there that have the MCP client functionality built into it. But if you want to just kind of test a raw connection or maybe the client that you're developing, MCP's GitHub repo provides this really cool tool called the MCP Inspector, and you can find it in the URL that I'm showing here. This is a way for you to fire up an MCP client and really take a look at all of the interactions that you can do. You can list things, you can get the resources, you can find out all kinds of information based upon the capabilities of the server you're interacting with. So similar to running the file system setup that we had with MCP Server, we're just going to prefix that with an npx command. Again, we're running the model context protocol, but in this case, we're running the inspector, which is going to be our client, and we're going to connect it to our server utilizing the same argument with the path. And you can see that the inspector fires up. There's a local host port that's sitting there waiting for you to click on, and then you can open that in your web browser, and then you can use the MCP Inspector interface that we'll demo in another recording that allows you to interact with the actual MCP server that you've got going on here. And you can see that our transport type is stdio, and then we've got a connection and then we're exchanging messages. So for those of you that are nerdy like I did, I immediately fired up TCP dump or Wireshark to watch this stuff on the wire just to see what it looked like. And we'll talk about that later on, how we can actually go through and use those call flows. What's interesting is we can use AI to go in and actually help us understand things like PCAP filters or PCAP files that we could capture from this exchange. So we might nerd out on that in another video. The other method that I mentioned is HTTP-SSE. Now that is in flux. As of the March 26 change log, the MCP specification is moving from HTTP-SSE in its current form to a new flexible streamable HTTP transport. Under the hood, it's really kind of HTTP-SSE, but it's a more flexible way of doing streamable HTTP. It also allows things like batching and some other stuff. So we'll talk about that another day. You can read here in this URL what the changelog looks like. I'm not necessarily talking about it immediately right now at the time of this recording because the streaming HTTP stuff is not fully baked into the SDK, so I can't really talk about it from an example point of view, but we'll circle back around there. I've got a link here in this bullet point that talks to you about what the actual streamable HTTP implementation is, so I encourage you to go and read that and get used to it. As of now, HTTP-SSE that's in the implementation and will be in the future implementation for backward compatibility operates like this diagram shows. Whenever we need to go and interact with a server, the client is going to do an HTTP post, nothing new, the messaging format, JSON RPC as we mentioned before, And when we go and ask the server to do something on behalf of these remote data sources we're looking at, the server will respond with an event message utilizing server sent events. So we'll look at that here in the next few slides. So in addition to stdio, which is really for local host connections, HTTP-SSE and the new streamable HTTP transport will allow you to also do that local host, but it's really also there for you to do client to remote server connections over HTTP. Now, let's take a look at a quick MCP message exchange flow here. So this is a MCP Quick Start server that is a weather app. I've modified it a little bit for our example here. But when we kick this off, our client will communicate to this weather app server that is talking to an external weather app on the internet. And we're going to do a tools list. We're going to create that HTTP post that we mentioned, and then we're going to have a method of tool list. And you can see JSON RPC 2.0 is our protocol version. And then we'll do some exchange there and get some information back around what the list of tools are. And then once I find the list or the tool that I want, I'll make an actual tool call. So I'll come back with an HTTP post from the client and say tool/call, and then I will name the tool, get_forecast, and then the arguments for that specific tool. In this case, the latitude and longitude of where I'm at, and where I want to get weather information, right? So then the HTTP-SSE response comes from the server back to the client with the actual event message. You can see event message. You can see it's still JSON RPC 2.0 is the message format. And then you can see the actual data of that response. This afternoon, the temperature is going to be blah. And so this is a HTTP post to HTTP-SSE message exchange. Now, I mentioned discovery in one of the earlier parts of the talk. Now, discovery can be quite confusing to some people, depending on where you come from an operational or a developer background. In many cases, we're used to discovery being very automagic, right? It is a client, for example, registering a DNS or a server registering a DNS, and then we can go and poke that DNS server and find out what we need to do and get on with our business. There are other things like LDAP or dynamic registries that allow us to not only register things, but find things and then establish communication there. That is not what MCP discovery means. What MCP discovery means is the capabilities of the resources we're interacting with. Okay, so when we do MCP configurations from the client to the server, they're utilizing this component known as direct resources. There's also a resource template, but we're talking about direct resources today. And so this is where I would go into my client and I would statically define an MCP server by a URI. So I would say HTTP localhost :3000, and that's my HTTP-SSE endpoint, or some other path to get there, right? So I would know ahead of time the information around my MCP server. I would enter that in there. That is not discovery. That is a static definition. Then when I do an initialized request and response and notification, that's where I am doing the discovery of what the server can provide for me. So when we say discovery around resources with MCP, it's really around three things specifically. It is the discovery of the server's supported capabilities, any kind of protocol versions, which today is the same protocol version for both client and server, and any custom metadata that may be unique to the server that we're interacting with. So let's take a look at this. So let's look at a resource discovery example here. So I've got another MCP server, which is SQLite, that I'm running in my environment. And in this case, my MCP application or MCP client is Claude Desktop. So I would go into my Claude Desktop config and I would enter in my MCP server utilizing the standard documentation that you see in the GitHub repo for each server. And then when I interact with Claude and ask, hey, I need to know what the capabilities are of SQLite, or give me a list of databases, whatever it is, then Claude will do a message exchange with the MCP server. And we can see here, the method is resource list. The server responds with the list of resources that it has in a very specific and specified way. The URI, the name, and then optionally the description and MIME type are in there as well. And so we can see in this color-coded flow here that the server responds with the URI about, hey, this is kind of what I'm about. This is my name. I'm a business insights memo server. Here's the description of what I'm doing, and then the MIME type that's there. So go and take a look at the documentation around these resources, and then go and start pulling this stuff off the wire once you implement your own client server implementation. And I think it will make sense to you very quickly what's going on here. That was a quick run through of what Model Context Protocol is about. And we're going to dig in subsequent videos and lots of other documentation around use cases, and then we're going to dig into those use cases and start assembling our own tooling around the clients, the servers, the full workflow, and then end up with how do we do that to help us in our day-to-day Cisco-oriented automation jobs. MCP is off to a strong start. You're hearing about it all over the place, and I think it's a really great start to a tool set that we've needed for quite some time. It is a young protocol, so there are some changes. I mean, the HTTP-SSE to streamable HTTP implementation change, those are the types of things that you start to see in these early implementations, but they're doing it in the open, and they're doing it for the right reasons, so this is really good. We mentioned what it's ideal for. This is really linking up AI-enabled applications and agents to tools, data sources in a very standard way. It really abstracts away all of the code complexity that you have to write inside your AI applications to get that done. And it really allows you to integrate MCP into all kinds of low-toil platform uses or IDE integrations where you want to programmatically interact with non-AI enabled systems, again, data sources, APIs, etc., directly from within inside that IDE integration. So it's really awesome for that. We also mentioned that we need to understand the bounds of what MCP specification is about. It is not an agent-to-agent framework. It is not a lifecycle manager of all of your tools and integrations with those clients that we talked about. It's not an LLM. It's not a data source. And it's not there to provide this massive registry of all the known clients and all the known servers, and you dynamically kind of have a matchmaking service to link those two things together. That is not what it's about, at least not today. We also took a look at MCP and how the clients and servers interact with one another, JSON RPC, standard input output. We looked at HTTP-SSE and some message format stuff. So we kind of covered the gamut here in our first video together, and we're going to get into a lot more practical implementations and use cases coming up. So I hope you're ready to go along with the ride with me. I appreciate it. We'll see you on the next one.